This week we are going to start looking at mixtures and solutions. This is one of those things that you guys kind of already know some things about, but you may not know that you know them yet. So we may be putting some vocabulary together with some things that you already kind of know. All right, so what is a mixture? Well, a mixture is when we combine two or more substances, and when we combine them, they keep their own identity. So like the examples that you see up on the screen right now. We've got our trail mix, bowl of trail mix down on the left. Um, Even though we've mixed all those things together, they still are what they are. They're still almonds. They're still, looks like peas in there. Is that French fries? I don't know. There's some cashews. Those things are still, they haven't changed what they are. They're just all mixed together. Same with the different colors cereal. Same with the drinks in the cooler. Like even though they're all mixed up, those are still, they're still themselves. Like that's still a bottle of Coke Zero and a bottle of Coke Classic and a bottle of Pepsi and a bottle of Fanta. So in your notes, the first thing you'll see there is two things that all mixtures have in common. Well, that's these two things, that they are two or more substances combined, and that each type of matter keeps its own identity. If you want to pause the video so you can put that into your notes, feel free. All right, so mixtures of solids can be separated. And this is going to be really important because a lot of your questions are going to be about how do we separate different mixtures. But mixtures of solids can be separated based on a lot of different things. So this confetti, for example, we can separate it based on color. We could put all of the purple confetti in one pile, all the blue confetti in another, all the orange confetti in another pile. We could separate it all based on color. We could also look at the size. We've got some big pieces and we got some small pieces. So we could put all the big pieces together. We could put all the small pieces together. And then we have shape because we have a lot of different types of shape in there. You've got some circles, you got some ovals, you got some just irregular looking shapes. You could separate it by shapes. So if you look at your notes, down where it says can be separated based on, go ahead and put color, size, and shape in the first three boxes. And the blank above, mixtures are two or more substances that keep their identity. So that was the blank from before. We skipped that one. So how do we separate mixtures? All right. So we've already talked a little bit about color, size, shape, but sometimes we can't. It's not going to just be solids. So we have different things that we could use. All right. So we can use density. So if we have a mixture of, say, wood beads and metal beads, we wanted to separate them quickly and easily, we could dump them in a container of water. And the wood beads, being less dense, would float, and the metal beads, being more dense than the water, would sink. And so we could very easily separate them that way. Whether or not it dissolves in water, if it's soluble or not. So these are all ways that we can separate mixtures. So in that, I know we just put color, size, and shape in three of them, but go ahead and put density, solubility, mass, boiling point, magnetic, and melting point. Put that in that table as well. And you may have to double some of them up. That's okay. So you're putting this in the can be separated based on box. So now we're going to talk about something that you guys probably already know, but you may not know the word for it. So a solution, and this is in your notes as well, a solution is a mixture of two or more substances spread out and not easily separated. Excuse me. Not easily separated, or they cannot be easily separated. A solution forms when one substance dissolves into the other. Now that should be familiar to you because we did some solubility, we did some dissolving last week. So here are just some examples. So we've got chocolate milk and we've got lemonade and we've got tea, where that's a type of mixture, but it's a type of mixture where they are dissolving. The ingredients are dissolving into one another and they form what's called a solution. All right, so a solution is a type of mixture. A solution is a mixture, but it's a special type where it dissolves, where something is dissolving into another. All right, and then on your next section of your notes where you're going to find 3 examples of solutions, I don't want you to use the chocolate milk, the lemonade, or the tea, but I want you to think through what are some solutions, and we made some last week. Think about the things that dissolved. You should have in your folder, you should have 3 things that dissolved in water, that were soluble in water. And so you could use those examples, or you can get online and find 3 examples, or if you can think of 3 examples on your own, go ahead and put 3 examples of solutions in those 3 boxes. So something that's not in the slides, but I do want to make sure I go over is the next box, the factors that affect the speed of dissolving. So I'm going to give you those 4, so you have to listen carefully. All right, so we are on the factors that affect the speed of dissolving. Okay, the first one is size. Just size. How much are you trying to dissolve? If you're trying to dissolve a pound of sugar in a droplet of water, that's not going to work very well. But if you're dissolving a little pinch of sugar into a large container of water, it's going to dissolve very quickly. So size is the first one. The second one, which is similar, is something called surface area. Surface area. And surface area is just how much of the substances are coming into contact with each other. So how are you able to spread them out? So that's surface area. And then the third one, which we did last week when we were doing our solutions, when we were doing our solubility, was stirring. Stirring is the third one. So if we stir it up, if we try to stir that sugar into that water, it's going to dissolve a lot faster. And then the last one, which is something we didn't do, is temperature. If you heat up a solution, excuse me, if you heat up a solution, it will dissolve faster. So if the water is warm, the sugar will dissolve faster. If the water is cold, the sugar will dissolve slower. So temperature is the fourth one. So we have size, surface area, stirring, and temperature. And most of the solutions, like the ones we've looked at, they are liquids, but some of them are not. Some of them are gases or even solids. So we can actually combine 2 metals. Now we have to heat them up to a liquid in order to do this, but then they will harden into a solid and they are a mixture. They're a solution of solids, of metals. And then a lot of gases are also solutions. All right, so separating mixtures. So I want you to, and it says to discuss with your partner, but I don't actually want you to discuss with your partner because hopefully you have your headphones on right now and you're paying really close attention. I just want you to think through how would you separate these particular mixtures. And in the boxes where it says separating mixtures, there's 2 boxes there. The first box is for the vegetables down on the left, in this picture down here on the left. And the second one is for, it looks like candy, is for the candies there on the right. So what are some ways that you could separate those? What categories could you put them in? If I said, hey, I want you to put these into groups, how would you group them up? So pause the video if you need to, and go ahead and write down how you would separate these mixtures. So as I said earlier, a lot of the questions that you're going to get on this is going to be how to separate a type of mixture. And a lot of times it's going to take more than one step. So you're going to have multiple steps in order to separate. So the example they give you here is I've got a pile of rocks, I've got sand, I've got iron filings, and I've got salt. If I want to separate the rock from the sand, and then the salt from the sand, and then the iron filings from the sand, how would I do this? So let's take these one at a time, and I want you to just think, if I want to separate rock from everything else. So think about rocks, think about their size and shape, and then think about the sand and the salt and the iron filings. And iron filings are just like, they're basically like iron dust. They're very, very small, kind of like sand and salt. How would I separate them? Okay. Hopefully you had an idea there, and if not, that's okay, because we're going to talk through it. So now my rocks are separated by that first step, and now I've got salt and then sand and iron filings. Well, think about how we would separate salt from sand and iron filings. What is something about salt that we learned last week that's different from sand and iron filings? Okay, hopefully you came up with a good idea there. And then finally, how would we separate iron filings from sand? So what did we learn a couple of weeks ago about iron that's different from most other things? Only iron and two other things share this particular property. What did we learn about iron that would help us separate the iron from the sand? So hopefully you had a plan on that one. We're going to talk through it in just a moment, but I do want to show you guys this first. So filtration, this is going to be your ways to separate matter. This is the last little box. Filtration is when you separate big pieces from little pieces. And if you've heard of a filter, like a coffee filter or an air filter, what that filter is doing is it's filtrating the air or the water or whatever. So this thing right here at the bottom, this is uh, this is a filtration device right here. So we have a filter going through because there's tiny little holes. So the little stuff is going to get through and the big stuff is not. Here's another example of a funnel um, being filtered. Now, sifting, as we're going to look at in a second, and filtration are very similar. All right. Magnets are another one. So if we have a mixture like we did in the example that has iron or nickel or cobalt, then we can use a magnet to separate those out. And then evaporation, if we've got a solution where salt or sugar is dissolved, we can actually evaporate the water and the salt or the sugar will be left over. And then the mesh screen and sift, very similar to filtration except that it's really for much, much smaller objects. This is some bigger pieces we'll get through here. This one much smaller will. A lot of times you'll see a sifter, like they're using it for cooking, and you'll see that as well. So I want to go back to this example, and let's talk through how you would separate it. So we could filter the rocks out. So we could filter the rocks so that only the sand, the iron filings, and the salt went through. Okay. So the rocks we've filtered out. The sand and the iron filings and the salt, and we could do these actually in either order. Because the iron filings are iron, we can use a magnet to actually pull the iron filings out of the sand. And it's actually pretty cool to watch. I will find a video for you guys to see it because it's really cool looking. And then we're just left with the sand and the salt. Well, salt, remember, dissolves in water, and sand does not. So we could dissolve the salt in water, and then we could run it through a filter, through a coffee filter, where only the water, the salt water in this case, would get through. And then we could always evaporate the water to where just the salt is left over. So you got to really think through what makes these things different in order to separate them.